Cool. Thank you for your interest in our journey from a manual to LLMs, like for scaling our product categorization. Let's first briefly introduce ourselves. So the man in the white shirt, that's Giampaolo, and the other one is supposed to be me, Ansgar, and we are data scientists at GetYourGuide, and we worked on this project together. To understand this categorization thing, it's also important to understand GetYourGuide, the company we are working for. GetYourGuide is a global marketplace for travel experiences. So it can be things like boat tours or bus tours or museum entrance tickets, but also more niche things like cooking classes or bungee jumps or something like that. Here are some numbers about the company. There are offices all over the world, but the engineering and also us data people, we are in Berlin, apart from a little office in Zurich. Okay, so let's first understand the challenge that we were or are facing with this product categorization. The categories for GetYourGuide play a quite big role, and that you already notice when you get to GetYourGuide. So how do most people reach GetYourGuide? That's still via Google, although AI is getting bigger, but still most people are typing something into Google, like photo tour in Rome, and then there are the well-known search results, so it could be this one from GetYourGuide, then some more results that we don't want to talk about, and there can also be this, So the first one, because it mentions sponsored, you know it's a paid one, so for us it's search engine marketing, and the latter one is just that Google found the page, so it's free for us, search engine optimization. But actually, it doesn't matter much, because whatever you click on one of these links, you land on a landing page which looks like this. So it's a page of GetYourGuide, which is for Rome and for the photo tours. And the challenge that we are facing is to decide for these pages, to decide which products to show. So what should we show here? Coming from externally is not just the only way that you get to interact with these categories. It also happens when you search on GetYourGuide. So let's say you are just at the general Rome page of GetYourGuide and you want to narrow down to something, then you can use these filters here, and they are also based on categories. They are more available. It's just a set. And yeah, when you click there, then also they are used to narrow down the products that are shown. And finally, also if you use the search bar and you type in the query Rome photo, there come suggestions, and these top suggestions here, they are also category based. So if you click on one of them, you land again on this page. So yeah, I think you got that it's quite important for us to have a good decision of which product belongs to which category. For us, also the scale is a challenge. So organizing these product categories for GetYourGuide means it's a multi-label classification, so they are not exclusive. One product can belong to many categories and normally does belong to many categories. And then in the first run, whenever we try out something fully new, we really have to look at this full cross-product. So we roughly have to classify 250,000 products, not just the currently active ones, but also ones that can get new availability. Then we want to be prepared. And we now have 600 categories, so it's quite a lot of pairs for whom we have to decide, are they connected or not. And then to keep it up to date, we have to now roughly decide for 1,500 products per day, which are new or which have changes, which categories they should belong to now. Okay, so let me at this point ask, has anybody of you already used or done some product classification or some text classification? Cool. And wow, a lot. I didn't expect that. And LLM-based? Also some. Oh, I wanted to invite for a discussion, but it seems to be a big group. So anything. Anyways, I'm interested, or we are interested in also hearing your results or experiences. In this talk, we want to present our journey, so from the first approaches of this product categorization and how it evolved, and then the final stage, the current stage, it's not the final stage, of our LLM-based system, where Giampaolo will present some details that are hopefully helpful for you, and then also a short outlook. So what are the initial approaches? When GetYourGuide started, I think a first version got online in 2009. Of course, the founders had to do something fast and simple to start with, so it was just a manual curation. So whatever product came on GetYourGuide, somebody at GetYourGuide had to decide which categories it belongs to. It was fast to start with, but of course it's a bit slow, it's expensive because you have to pay somebody to do it. It's inconsistent because humans don't necessarily agree directly, and it's not easily scalable. So the next iteration, which roughly happened in 2019, is then a rule-based system. That was then based on supplier input. So when a supplier puts a new product online, they are asked some questions, for example, which transportation type is used, or to provide some tags about themes of the product. And that was then used in a rule-based system to decide on these categories. And the upside of that is that now some work was done by the suppliers, and we only needed to create one rule per category. That was the work on GetYourGuide side. But of course, there were also downsides. So one is the dependence on this additional supplier input. We noted, for example, that this transportation type, if there's something very infrequent, let's say balloon, then the suppliers maybe didn't see that was also needed to put in as a transportation type, and that wasn't good quality. Or it could even be gamed by the suppliers. So if they figured out, if I tag a lot of things, then my product is shown more often on GetYourGuide on more pages, maybe they have the wrong incentive there. And finally, it's difficult to introduce a new concept, because then we had to backfill all these tag data, which is difficult. That's why then we introduced the semantic natural language processing model. And that one translates this English category name, like photo tours, into a vector. Also, all the product texts are translated into a vector. And based on that, it's decided which product belongs to the photo tours, just by taking a look at the angle between the vectors. So if the angle is below this threshold angle of theta, then it would be considered a photo tour, and above, then it's not considered a photo tour. We used a model from Hugging Face with roughly 1,000 dimensions. And we had to fine-tune it on our own data so that the quality got good enough. There, the positive thing is that now we only relied on good quality input, so not these tags by the suppliers anymore, but just text that also our users could see. So if it's bad, then it would be reported to us. It was scalable well to new products. And an A/B experiment showed that the business metrics stayed the same. So we moved to a better scalable system without using quality. Downside is that scaling to new categories did not work as easily as we thought. We originally thought, okay, maybe for new categories we can just use a global threshold, and that works well enough at the beginning, but it didn't. So we saw for some categories you need a very small angle as a threshold, for some a very wide angle. And there was a dependence on good training data. We needed a lot of training data. There we used the old tagging, so it was difficult to improve further on that. So that's why we then try to also include some performance indications from how much did a product get clicked on a category page, and that actually did some improvement on the business metrics performance, but it only works for products and categories where we have enough data, so it didn't solve the problem for everywhere. So that's why we then switched to try out LLM-based. It was also the time when ChatGPT came along, and then Giampaolo tried out a lot of different things that he will now talk about, and we finally got to this LLM-based solution.
So hello everyone. Let's start then by going through the basic. What is an LLM? No, I'm joking. So let's start first attempts with OpenAI. So first we started working like with most straightforward approach. So and then we created like a prompt with just one product and a list of small potential categories, asked it to tell which categories the product should be in. But the problem was that the output was free text, so quite unpredictable. And for example, here we can see a prompt example for a Vatican tour. We can ask, like, this is the product. Those are some categories, which one should be assigned to. And we can see, like, every time that you try with different products, or even the same, sometimes you get a list, sometimes some text before, and then another list in a different way, or sometimes you get another list with some exception in some parts. So that's when we decided it was not the right idea to use it. Then we thought we had the solution. OpenAI released the JSON mode. So did someone of you used JSON mode in the past? Okay, so you know what I'm going to say now. So we were thinking, yes, that's nice. We start to have JSON outputs. So great, it's working. But then the problem was they were still broken, because yes, you have a JSON, but sometimes or the formatting changed between calls, or there were some unescaped quotes, dangling commas, models keeping characters. So yeah, not really useful also at that time. Then finally, OpenAI released structured outputs. How many of you use structured outputs? Okay. Also called function calling on tool calls. Okay. Yeah, it's the function calling tool calls based on LangChain, but yeah, it's the same type of concept. It was a great, like, huge leap forward, because it allowed us to define precise output schema, allowed us to define also the pedantic class. For example, in Python, we could specify the exact field names, the data types, like strings, lists, and whether they were required or not. So finally, we could enforce a consistent and predictable structure for every single call. For example, in the first step that they tried, like say, hey, those are some categories that you need to use, and then as a string, and then we got it back every time. So this was also our turning point, because moved the project from an experiment type of project to a practical engineering challenge, where we could reliably get always an output as we wanted, and we could start running tests with different prompts, different schemas, and see how it would work. And so this gave us also some confidence of the success of the project. So then let's start with the prompt engineering part. Now that we have a reliable output format, we were thinking, okay, let's try to maximize efficiency. Let's batch as much information as possible into a single request. So we were starting to add multiple products and all the categories at the same time using the best performing model at that time, GPT-4o. So we found out that the task was quite complex, hard to perform multi-label classification for several different products. So the results were quite poor. So I was probably overwhelmed by the complexity, and then the structure of the output was pretty complicated for this type of prompt. Then we made it a little bit simpler, one product with all the categories, still using GPT-4o. The quality, it was quite better. Probably concentrating on one single product, the model could focus better or analyze more the text of the product and assign the categories that were related, especially also some more fine-grained categories. So results were looking good. The problem was the cost. Too expensive at scale. We need to run this for all the products. So running every single one of them like this, it would not work for us. So we need to find another way for scale this up. Then we tried same setting, one product, all categories, a more smaller model for mini. The problem here, the drop in quality was too significant for us. The mini model struggled with the nuances that were required. We had a lot of categories, was 600. And yes, it could or classify always with the same one for some products, miss some nuances some small ones. So in that time, precision and recall were too low, and so results were not reliable, and we didn't move through with this approach. Then we tried multiple products and one category, so we flipped the case. We tried both with GPT-4o, GPT-4o mini. The thing is here, the results also were kind of fine. The prompt became huge at that time. The problem was to find the balance between the number of products that we put in the prompt, and then also when you get an answer, there is hallucinations problem. Every time that you put some IDs or something to match all the products in one prompt, when you get the output, then you need to be able to match back those IDs with what you had. So the more things you add, the more probability of hallucination you get. So it was also not a great way for us. Then at the end, we said, okay, let's go to basic. Let's try the most simplest way. One product, one category, using the smallest model, but good enough that we could use at that time, GPT-4o mini. And the task that we tried was a simple yes or no decision. And this, we found that model was quite good at giving these answers. Also, when we started to use the output schema, a little bit more complicated, for example, adding reason, confidence in the decision part, we saw that this increased a lot the quality of the results. So it was kind of like thinking mode. And we saw it in the actual numbers that when we ran it, it was quite improving the results. So it also helped us also debug more details, how we are writing the prompt, what's happening in the model, and which answers do we got at the end. The problem of this approach, as you can think of, then we need to scale this 250,000 products, 600 categories, so combination is a lot of API calls. So let me give us some examples with our best approach that we saw before. For example, here we have one product, Fiat 500 vintage city and photo tour in Rome. Then when we ask this product to match it with photography tours, that's an answer that you will get. In our case, like reason, confidence, and decision, we actually wrote it in this way. Sometimes it's better because if you put first the decision and then the reason, usually it doesn't work in the thinking step. So it's always better to put the reason before the decision. And here we also added this confidence that was quite helpful also for us. Then here it's pretty clear, yes, confidence high. When you ask this for water activities, it's also clear, decision no, confidence still high. If you had for family friendly, here that's a little bit more tricky. Yeah, we still see here the decision is no, confidence is medium, probably because like if you want to try to do in a Fiat 500, put a family in, I don't know if it will work. In Berlin, for surely not. But this was in Rome, so maybe it could work. Like, that's why probably the confidence was medium in that case. Then now let's see this hybrid approach that we found. Like we wanted to use that way that we found that was pretty good. Then we just needed to scale it and see if we could balance costs and time. And we found a quite good approach to achieve that. So how do we get this? It's based in 4 steps. So the first one, using semantic vectors. So we start to use OpenAI vectors to create a first fast ranking of all the products based on one category. Then we group them in batches. We use the OpenAI batch jobs that was quite cheaper than normal API calls. Then at the third step, we implement a custom early stopping that would stop at certain points during the batches. And finally, we automate everything together, making sure that everything would run, handling also errors and problems during this workflow. Now I'll go more in the details of every step, so it should be a little bit more clear. So first of all, as we said, we have the LLM that before sending the data through the LLM, we need to rank them using the OpenAI vectors. So for example, when we use the photography tour category, we will start to see when you order them that some photo-related active products will start to go on top, and other ones will start to go down. And this helped us also prioritize which product to classify first. Then we group them, as I said, in batches. Did some of you here used OpenAI batch jobs? Okay. So it's the same thing as the API calls. You just need to create this batch structure file that you can send to OpenAI. You pay 50% of the discounted price of the normal calls, so it's quite a good deal, I would say, if you need to do a lot of calls. The only thing is that you have some limitation on the time that you get an answer. So they will process those requests in parallel, and they have a 24-hour SLA for the answers. So it was pretty good. Now the thing is, when we start to create those batches, we needed to create this early stopping mechanism, because we were expecting that with the first ranking, using the OpenAI vectors, we would get some good approximation of which one should be assigned to which category. So every time we got an answer from the batch job, we will check the percentage of connections with the category, and then use a custom threshold that we would say, hey, if the percentage is lower than this threshold, just stop and don't process the rest. So this was quite helpful for us, because it helped us not process too many products for some niche category where there could be just I don't know, 100 products. Then the final piece was also the parallelization of this process. For how it was structured, it was also possible to parallelize for all categories, because it works independently for each of them. We used the round-robin approach. So the only hard limit was, as I said, the 24 hours SLA from OpenAI batch jobs. But then once you start the run for one, for example here photography tours, you can start for all the others one at the same time. Entry tickets, guided tours, water activities, and so on. Then we needed to automate this entire process and make it fault tolerant, because there could be many problems with the OpenAI batch jobs, especially OpenAI can even have problems on their own side. You will get the same output. There is just one other column that's called error in the answer. So for some products, you need to then read what happened in the error. There are some codes that then you need to translate which type of error it was. If it was an error on our side, maybe there was some characters that were wrong in the call or some problem on their side. So we needed to automate everything, making sure that would run without like blocking us in this process. So for this, we used Airflow to orchestrate everything. Also because we didn't want to keep compute running at the same time, because waiting 24 hours, it's like, doesn't make sense if you're not doing anything, just like checking if you got the message or not. So this was quite crucial to automate everything and make everything work for all the errors. Then finally, the system also was designed to keep our catalog up to date. So when, for example, some other teams can decide to create new categories, and they just go through the same process. We start the same process for new categories, and it worked pretty smoothly with what we had. And also, as we mentioned before, there were 1,500 products or updated products that also need to pass through this process every time. So we were able to like manage everything together in this full automated process. And yeah, it worked quite well for us at the end. Now let's go through the impact of our solution. Yeah, and Ansgar will talk about what happened at GetYourGuide. As you can probably see, was a good result.
Yeah, as you can tell, we were quite happy with the results. I don't think we got really rich by that, but still we were happy.
Not us.
So let's first look at some examples. Coming back to the Rome photography first. So this is actually how it looked before the LLM approach. It's also it's a selected example, so not everything looked that bad before. But yeah, so for example, yeah, it's not really photo-related. The first result, maybe like with this panoramic open bus, can be good for taking pictures, but yeah, not really very good. And this is how it looked afterwards. So now everything is photo-related in the first result. So that's a very good example. Another one we saw is this Dubai air and helicopter tours. So there everything is kind of related at the beginning, even before LLM. But yeah, this skydive, it's not really a tour. So that was also then filtered out by the LLM. And one specific example we wanted to show is, yeah, this Discover Scuba at the underwater sculpture park that was connected before to snorkeling. And if you look at the text of this product, it even mentions snorkel, but it says if you swim and snorkel, then scuba diving is your next exciting adventure. So really difficult for a vector-based system to decide that it shouldn't be snorkeling, but the LLM found it. But yeah, these are just examples. Let's take a look at the overall results. And there we first looked at offline evaluation. And there the quality improved quite a lot. So the MCC, that is Matthews correlation coefficient, it's a better F1 score that improved really noticeably. And that's because the recall improved a lot and precision simultaneously improved slightly. We could also improve the coverage by this step. We were able to add 50 more of the existing 325 categories. They had to be taken out before because the quality of this vector-based approach wasn't good enough, but with the LLM, we could put them into the automation. And we enabled another team of adding 295 new categories, like expanding to more niche things, which also had a quite positive business impact. Speaking about business impact, we also introduced this LLM-based system as an A/B test. And yeah, by the way, this is, as all our A/B experiments, it uses this framework that Konrad talked about yesterday. Hope some of you had seen the nice talk. And our A/B experiment resulted in a clear significant improvement of the conversion rate by plus 1.3%. also in the same ballpark, the quota rate and a significant drop of the bounce rate. Just so that everybody understands, so conversion rate is how many of our visitors book something. Quota rate is how many of our visitors take a closer look at least one product, and bounce rate is how many visitors come and don't do anything and just disappear. So very good results in the A/B experiment. So we are quite happy with this system, but it can always be improved. And some of the future work is already ongoing. One part is that we are trying out to include human category definitions as an additional input for the LLM, and that has improved the quality for some categories already, and we are trying it out for more. Also, using an alternative title in the LLM prompt was helpful in some cases. So one example is the category flower farms and festivals. When we took a look at the products that were selected for it, we found some of them were not related to flowers, but just to festivals. So difficult for the LLM to understand. So just renaming it for the LLM with flower farms and flower festivals helped. And potential next steps, there are on our roadmap quite a bit of options, but I want to present some of them, or the most important ones. Trying out better and or cheaper LLMs, maybe first on OpenAI, but not restricted to it. And then later, a bit more difficult to automate the prompt optimization from wrongly tagged examples, or even model fine-tuning, as Marco has presented in a different use case yesterday. Okay, it was not just us in this project, a lot of teams, but yeah, we want to say thank you to them too, but we cannot name all of them. And also, we are hiring, and thank you for your attention.
Thank you. Very nice presentation. So we have a couple of questions from the app. Okay, I'm starting with the most ranked one. How representative was the confidence fields? Was there a quantitative testing for confidence field to check how good it works?
Confidence?
I think I can.
Yeah.
So,
Yes.
Did you get?
so
Yeah.
maybe Giampaolo has done some more eyeballing, but then in the end, for what we put live, we haven't actually used the confident field yet. So just using the yes, no was good enough. And I think introducing this confident field increased the quality of the yes, no decision, although we don't look at it. I mean,
Yes, we don't use it now, but we used it like as a kind of sequential thing. We started having just the decisions, then we added the reasoning that improved the scores, and then we had the reasoning plus the confidence and improved even more the scores. So it was just for still using just the decision, but improved the scores from the output. So.
Thank you. So the next question is, how do you evaluate accuracy and quality of the categorization at scale?
Yeah, so we actually took quite some effort to set up offline evaluation data, and with an independent model tried to set up an example set for each category where we would include some clear positive cases, some clear negative cases, and then got it tagged by humans with a team that is specialized in this, and that we use as our ground truth, and that's the data that we run the offline evaluation on that we presented here.
One thing here is also when we have this offline evaluation data, we also run the scores for every categories, and then we group them We do like macro average, micro average, and then we check by multiple runs. Then we try to find outliers for which category was performing the best, which one was performing the worst, and trying to find if there were some problems in the model or why it was happening.
Thank you. So next question, how did you create different vectors for your products depending on the category?
So the vectors were the same. We were just using the OpenAI embeddings for that. We just then did causing similarities with the category. Every category has its own vectors. Every time like you do the similarity, then you have different similarity scores for every category. So the vectors were the same. The embedding space was the same.
Thank you. Next one. How do you come up with the categories? Are they derived from the products as well with a data-driven approach? That could have been clarifying clustering approach. So I'm just reading as it is. If
the last part I didn't understand.
Yeah.
Just last sentence.
Okay, that could have been a clarified clustering approach.
Ah, yeah. So actually, there was a system to find new, or there is a system to find new categories. Like historically, there was at GetYourGuide there was a category tree, just human-made, and yeah, because reclassification is always difficult, so it's still somehow included in our category system. But there are then new categories added where another team saw that something is missing by just looking with also using LLMs at the existing products, also at search demand. And that was also quite successful project, but both of us were not involved.
And one thing, it's also a multi-label classification, so you cannot create now a tree from the classification, so you need multiple, you can assign multiple categories to one product.
Thank you. Next one. Could you elaborate what exactly was the problem with steering the model to produce consistent outputs? Did you need some complex output schemas? We were successfully using GPT for text classification even before JSON or structured output, where I think and did not encounter too many problems with schemas. Yeah, quite long one.
So yeah, the problem was that when we tried for 10 categories at the time, it works. The problem when you start to put more categories, like it was 600 something, then it's not consistent, the output. Probably was too many things in the prompt, but yeah, it was not working.
Okay, another one just arrived here. Have you tried dimension reduction techniques when working with semantic vectors? If so, how did you affect the quality?
So in this project, as I remember, we haven't. That was also not a problem. So at some point, if we would still use that approach now, it would get a problem of too much data, and then we would have to use something like it. But yeah, so far it works.
Thank you. Any question here in the room? Okay, let me.
Did you try using GraphRag?
So we didn't use RAG.
Well, I was more concerned about the graph, right? So you're pumping your categories into the large language model, basically as flat categories, and you're not showing a relationship between those categories, as I understand it. And what you have is clearly a hierarchy, a graph of categories, an ontology, and something like GraphRag is built for exactly this kind of recall.
Yes, but we don't have the graph of the TCs. Like
you just said you had a tree.
So that was the starting point, but then, so I think that's kind of the historic background. But now the decision is totally independent, so it's not a structure thing anymore.
Okay, but that's because you're ignoring the structure. The activities are actually in an ontology, right? You have activities, and then you have photos, and you have tours, and you have swimming, and all of these things are related in a conceptual space in an ontology. And this is, I would really encourage you to look at that. I'm sure you would lower your OpenAI bill quite a bit.
Yeah, actually one thing that we are working on is like creating graphs for the categories. So it could be like one of the options. We were looking at a way to find problems, like using the graph to find errors from the output and where to fix it. But yeah, could be an option. Like the thing is, then we needed to create the graph if we want to use GraphRag, but then we needed to also evaluate the graph, and we didn't know what were already the categories. So it would create two things at the same time. We need to evaluate. And it's not that easy because, for example, to create a graph here with 600 categories, you need to check all the possible combinations of those. So then you need to evaluate the graph, and you need to evaluate the output of the model. It would create, like, doing everything together, it's a bit of over complexity, but yeah.
600 is not a big number.
600 by 600 is a little bit.
Okay, so thank you also for insightful talk and for bringing some practical applications. So my question is, I wonder, so why in your project you consistently used OpenAI models? So are there maybe any, so is it just because they're the first on the market, so you started with them and continued then? Or does OpenAI offer some additional maybe features which make it much easier to use them in production and industrial contexts?
So, good question. We started with OpenAI because we have the enterprise contract with them. So it was easier, like just take an API key, and then at that time, also when we were looking for like ranking of LLMs, this was the best one, GPT-4o. So it was pretty straightforward to use. Then when we already had the setup for OpenAI, then we wanted to have a cheaper LLM. So it was just plug and play, just change the model name. So it was easier for us to iterate on that. And then the batch job was just OpenAI had that way. Like if you, I think, consider the price of batch jobs, it's still probably one of the cheapest at the same level. For example, if we check Elo scores for LLM leaderboards, it's pretty good deal.
Thank you. One more question here.
So one of the side effects of this system is that before, people who were posting these activities had a little bit of control over how these things are tagged, and now they don't. Have you also put things in place where they can come and say, hey, like this is wrong, like this needs to be fixed, or is it that no, the machine now does the job?
So the suppliers can reach out to GetYourGuide, and we have a system where wrong taggings, like missing categories or wrongly connected categories, can be reported. And then there's a system to put them first in as overrides, and then we use those cases also to improve the model over time.
And a little bit of control is still which text do they write for the product. So they have a little bit of leeway there, but good question.
Thank you. So we still have some time. Any other question here? Okay. Then, if not, thank you very much.
Thank you.